Hello again, lovely people. It's teardown time as far as the electronics go. We're going to basically probably tear out everything. The only thing I will leave for now will be the PWM controller, since that's attached to all of the servos. But I most likely will take that out as well, because I'm pretty sure what I'm going to do is lay this all out on breadboards for us, so my next video we can test the circuits completely and find where the problem is. There's been some good feedback on the comments, which I'll talk about during the disassembly, because there probably won't be much else to talk about. I may even time-lapse some of this depending on how long it takes, but it really shouldn't take that long. You will see me clip some wires because some connections are just soldered with short wires. For example, these sensors that I last put on there in development, that's what we do. So that's the whole point of this teardown, is the rebuild. We're going to rebuild it with nice wiring, better connections, no DuPont connectors to cause interference, etc. I have a little bit of shielded cable on the way for the data lines, SDA and SCL lines, as well as a nice terminal block rather than using homemade ones, because it's got a nice cover for protector and all sorts of stuff. So in the next video I'll show all that. Alright, so let's start just tearing this down. As I said, there's really probably not going to be much to talk about, so I will just talk about some of the comments that were made. So one suggestion was, like I just mentioned, shielded cable. Of course, the length of cable is important. And for history, for those who don't remember or haven't seen my previous videos, this problem all started happening when I added the whole nano circuit in the head, which added to the SDA SCL lines. So I think that's where the interference is coming from, and it only seems to happen when the motors are running, not necessarily and talking to the nano circuit at the same time, but it's almost definitely on that circuit. Now, I still suspect I have a ground issue with the nano circuit, so that may be causing the problem, but it could also be one of the common problems with the data lines, which again, shielded cabling was one of the suggestions. Yeah, I knew I could just pop that one off rather than unsoldering it. Hopefully nobody saw that. Yeah, anyhow, the cover's off. So yes, these connections I soldered all, and it's kind of messy and ugly, and DuPont connectors to connect up the reset button and the buzzer, and so that's all going to be redone into one nice, one thing I did get already in shipment is nice ribbon cabling, and I have a few different widths, or number of wires I should say, so we'll be able to make some nice cables instead of this mess. So let me zoom in here a little bit for us. I'm going to put all the components here so that we'll see at the end what I actually have to deal with. And let me zoom in a bit here, and we'll get to work. Alright, so because I have the wiring diagram, which is pretty tight, I'm not going to worry about where any of these wires go. I'm just going to take stuff out. So yeah, another suggestion that I've read up on is using resistors on the lines, which I tested in this setup, and for a while I thought it was working, but it proved to not be because the problem came back again. So that's why I really suspect it's an interference, or it's all these DuPont connectors, because I'm sure it wouldn't take much jiggling in these connections to cause interference, to cause the data line to just choke for a second. So these are the SDA and SCL lines right there. So I am using, straight up DuPont connectors. I mean, look at it. I pulled that one right off of the board. So the connection for these two lines are just DuPont connectors on the Mega. So that in itself could be the problem. But we're going to rectify all of that. Okay, so now that I got some wires out of the way. So here's the MPU unit. MP6050. I'm going to take that off first since it's right up top, and you want to install this pretty much level if you can. I think I mentioned this in one of my previous videos for obvious reasons, because that's really the whole point of using it, right? Of course, when she starts up, she levels herself anyway, but you still want this sensor to be as flush level as possible. So in this one, I did take the time to solder the wires nicely to it. You probably can't see that without me zooming more, but then of course the other ends were just into the screw terminals and DuPont connected to the Mega. So we're gonna fix all that, like I said. Alright, let's unscrew our 5-volt and ground terminals. Alright, so there is our terminal block. So that I'm going to replace most likely. I mean, it's pretty safe. I put a piece of pad on underneath it so that none of the contacts can contact anything. But these are all still exposed. And honestly, I'm not all that crazy about how these work, especially just into, tinned wire tips. They don't hold the greatest. So we'll see what the commercial version is. Okay, so the MPU unit is out. MPU unit is out. Let's put that down there. All this wiring is for the PS2 remote, so we can get all this out of here. Again, all DuPont connected to the board. Just going to toss all wires aside because I'm not going to reuse any of these. Look at this mess, guys. I mean, this could very well be my problem, but honestly, I really haven't touched this wire in much other than putting the wires into the ground block and the SDA line block. I might have added a couple things to the Mega itself. Yeah, so here are my SDA and clock lines, both just DuPont connectors, right connected to the board. Yeah, so I mean, I've been playing around with the body design, right? You may also remember from my previous videos when we were extending the body, I decided not to tear apart my electric components to extend the body cavity, but to add these two extension pieces. And honestly, I'm kind of glad that I did, because I have a feeling if you make this one big tray like the centerpiece, you'll definitely need good structural pieces like I've added to this. And in fact, when I have her naked of electronics, I may fix some of this as well, but we'll see. So there is the SDA SCL line terminal block. So this is probably a mistake too. But check this out. I don't know if you guys made it this far. You know what? I'll show that in the next video. Sorry. It's unrelated to disassembly. So here I have another. This one is the 6.8 volt line and ground terminal block. So that's all that terminal block is. I don't see a problem with that. It's just 6.8 volts. Okay, a lot of these wires go down underneath, so we'll have to take those out when we get down there. boy, all these connectors. I could see where my problems may even lie. All of my suspected problems may not be it at all. It could just be the poor connections. Alright guys, so we are down to just, let's call it the motherboard, the Mega, and the main buck converter on this board. And this wire I cannot disconnect, but everything else is disconnected. I did have the sense to solder the power wires to the Mega, but those aren't as important as the data connections being absolutely connected. So, alright, let's flip her over and see what we can take apart from underneath. So this stand is definitely not designed for both orientations, but it does work fairly well. It scared the bejesus out of me, but... Alright, these pieces I just have in there to protect the electronics. They're just light cell foam while I have the battery in there so it doesn't shift around. And this, you know, I mean, it doesn't look bad, but this is pretty much just the servo wires. There are really no DuPont connectors otherwise. There is the small buck converter here. I don't know if you can see that. Let me get my arm out of the way. This small buck converter here taps off the 5 volt buck converter, which takes the 6.8 in, and this goes to the nano. Okay, and then here is my battery monitor circuit, which monitors not only the battery voltage but as well the amperage being used. But that I have a slight issue with the circuit. I'm pretty sure that's not causing my ground issue. I really think my ground issue, if I have a ground issue, is in the nano circuit. And then under this munkin of wires here, whatever monk it is the PWM controller for the servo boards. Out comes the buck converter. Okay, that's our high amperage buck converter. They're advertised as automotive because they obviously can handle over 12 volts. I think it's up to 24 volts. But the point is the high amperage. And there we go. That's the Arduino Mega. I cannot remember the model number, but it's obviously a small version of the Mega. Which if you're this far in this video, you're interested enough in this project that you know what I'm talking about. Alright, I think we're done with the cavity here. We can go into these other sections now. I don't want this video to be an hour long on you guys. So let me try and take the nano circuit out. Alright, so here I could just pop the nano out because it's in pin headers. And I do have to do that to program it anyway, or update its software. Otherwise you have to disconnect the clock and data lines, so you can't connect it to upload. Now this is not just terminal board, obviously, because it's got the adjustments for the OLED and the brightness for the RGBs too. So I may not use that board that I have for the Nano. Just use this. Again, we'll test it all. You know, that's what this is all about. Okay, so the head. This stuff's all glued in. It was really the only way to do it, and to do it well, and to not have any problems, and all soldered, right? But I did again terminate them with pins. So I mean, not the end of the world. I don't think I have connection problems with these. It's more of the way that I did it with this wide pin. I really have to change that design and make it tighter. Oops, sorry. And so that it doesn't get bumped by the motors and disconnected. Otherwise, I probably won't do anything with this part of Nova, even though I do have the new head design, or I shouldn't say design, but you might be able to see that the plaster of the wall is thicker on this one here, which would fix my broken tab issue, but I may live with it because, again, like I said, these components, I probably wouldn't even be able to get them out. The screen I will, because that just slips in there. That's not actually physically glued in, but it's in there pretty tight, and I won't get it out with all this, so I'm probably going to stick with this head. We'll see. Alright, so that's it for this end. The other thing we have left over here is, or are, I should say, the two buck converters. One that goes straight to the Mega. So you know what? Let's clip this wire at the Mega, since I can replace that easy. Alright, so that's off. Crash! Blooper reel. Okay, and then we have this buck converter, which I think at this point is out. Yes. Okay. And the PWM controller is out. I love this device. I really, really do. On my Hexapower project, I had to use 2 of them because it has 23 servos and this only does 16. So when I learned that you can actually daisy chain these together up to, I think, like 16 of these, which gives you like 128 servos, it's pretty fun to think about what you could do with that. So anyway, bottom cavity empty, nothing but servo wires. Top cavity empty, nothing but PWM wires and servo and power wires, some of which can come out now. Okay, the only last thing is the rear end, which is where the power connectors and switches live. So let's put her back half-ass on the stand here. And pop the back cover off. Hopefully I've disconnected most of these wires. Should have. What else could they be connected to? Oh, a wire tie. Okay, let's get in there and clip that. Carefully, so not to clip my wires. Not that it matters right now, right guys? Alright, so we got one main connector right there for the high amp switch. And then the 6.8 volt switch is a bit annoying because it has an LED in it, so you have to run both power and ground to it, which kind of mucks up the circuit a bit as well as leaves more room for fault. But I don't, you know what, Steffi went ahead, one of my viewers, and put together her version, and she's done a really great job. She's actually got it all wired up and working great. And we had talked about my ground problem, and she did wire this switch a little bit differently. So, Steffi, if you're listening, I may be reaching out to you to see if my problem still exists. I'll have you help out looking at the breadboard version of the circuit and tell me how you did it and see if it fixes my problem. Alright, so there's the rest of the power wiring. And that's it, guys. There's a naked shell. I might as well take off the last of her body panel. And we'll have the naked shell version of Nova with nothing but servos. Let me zoom back out again here. Oh, and by the way, this is what I'm talking about. When she's in these positions, how the empathy kicks in. Poor girl. We will rebuild you, I promise. Okay, so there we go. An empty shell. Wow, she's so much lighter, believe it or not. I mean, components add up, guys. I think some of you have asked, and maybe you've seen it in the comments. I don't think I've mentioned in video, but fully assembled how she was before we started this video. She's just at nearly exactly 6 pounds. Right now, my brain is guessing her to be about 3.5, maybe 4, but doubtfully. So we took out, including the battery, of course, a good substantial amount of electronics. So maybe on reassembly it would be cool for me to just throw the Mega in there and the PWM controller and set her loose and see what we could do. Yeah, I'm just kidding. Oh, she's so much lighter. I'm holding her with one hand and can tell. Alright, so anyway, there's my busted bottom panel, which I have to reprint and put back in there. Otherwise, we won't see this part of her for a while. So let me put that aside. And let's get the stand out of the way here. And here is what we are left with. Okay, so to recap, the cover is going to have some kind of circuit, probably a circuit board that sits there connecting all this stuff together, and then just a nice ribbon cable coming from that. And what we have to deal with here is the reset button, which I may end up moving to the rear, which some of you have done and talked about. We have the connections for our PS2 remote, and then we have the 3 IR sensors, one of which is missing because I tore it off at the beginning of this video. Oh, and then also the buzzer, which doesn't necessarily have to be here. I just put it here because I'm tapping off the ground of the reset button. So yeah, we'll have that bit of hardware to deal with. Okay, then we have, like I just showed, the rear cover, which just has 2 switches, and then the meter for the 6.8 volt line. So we can put that aside. And then we have the front cover, which I reviewed the hardware in there. And this hardware all connects to the Nano. Which, here's the circuit board for the Nano. And here's the Nano itself. So those will go with that. Alright. Now, electrical. So here we have the main buck converter. All these screws that escaped us. Then we have our 6.8 to 5 volt regulator. And then we have another 5 volt just to keep the voltage stable going to the Nano circuit. So that too I may rework and not use 3. We probably can just get away with the 1. Okay, then we have our MPU unit. Then we have terminal blocks. 3 terminal blocks, which will probably be replaced. Then we have the battery circuit. Then we have the Mega itself. The PWM controller. Wires, 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 connectors, wires. All going bye-bye. Alright, so there we have it. And then of course the battery, and then our sensors from the hood. So we're going to breadboard all this, and we'll come back and do another video. I'm not going to shoot a video of me breadboarding it. I'm sure that'll drive you guys more mad than this video probably did. For those of you who are still watching, thanks so much for watching. Like, share, and subscribe, and we'll see you in the next video. Thanks, everyone.